Mark is the CEO of Biosynthetic Technologies, and Mark will be giving us some insight today on a comprehensive evaluation of sustainable raw materials and lubricant production. Let you take it away, Mark.
Thanks very much for that. Welcome, everybody. Thank you for taking the time to sit in on my session. A little bit about Biosynthetic Technologies. We are an innovator of oleochemistries. And I like to think of our company as where sustainability and performance converge. Our vision is to continuously deliver innovative solutions for a sustainable future. And our plan is to be the premier bio-based product supplier globally. So we manufacture, a little bit about us, and then I'll dive into the sustainability aspect. We manufacture a molecule called an estolide, which is bio-based, biodegradable, synthetic base oil, which can also be used as an additive. We look at ourselves as a sustainable alternative to petroleum and a variety of other products. They're eco-friendly alternatives, and they're actively being sold into industrial lubricants, metalworking, personal care, and a variety of other applications such as elastomers and plastics and things like that. So it's a pretty versatile technology, and we're highly focused on the sustainable future. We all know that the world is demanding more and more sustainable options. BlackRock private equity is making sustainability their standard. You've seen many lawsuits in courts with the major petroleum manufacturers. There's a big uptick in green venture capital. ESG, environmental safety and governance, is becoming a big driver, and pretty soon the Securities and Exchange Commission within the United States will mandate ESG descriptors and disclosures in financial statements. But despite all of that, we still continue to consume $33 billion of petroleum every year. And that's almost 3 trillion gallons of oil. And we know that we need oil, we need petroleum. It's not going away anytime soon, but we also know that it is finite. We know that when it gets into the environment, it's persistent and toxic, as well as bioaccumulative, meaning getting into the biology of various animals. And, you know, there are applications where petroleum is mandated and required, but there's also a lot of areas where we can use more environmentally sustainable alternatives. There was recently a study done at the National Lubricating Grease Institute of their members, and they asked the membership what was the most important aspect of sustainability for their companies. And the single largest response was their own corporate social responsibility initiatives. So a lot of companies are looking at themselves in the mirror and saying, hey, we need to be more socially responsible. The next largest response was efficiency improvements, saying, okay, so we're looking at sustainability, but through a way of energy efficiency, which significantly reduces carbon footprint and makes companies more efficient. And then third in the list was customer demands. More and more of their customers were saying, hey, we need you to be more sustainable, more environmentally responsible. In terms of some of the smaller aspects, it was regulations. Despite the fact that there's increasing regulations, there's finding ways to reduce costs, and then there's public perceptions. And a very small amount said that that was part of their corporate strategy. So what is sustainability? Well, if you look at Webster's dictionary, it means the being able to be used without being completely used up or destroyed. It means involving methods that do not completely use up or destroy natural resources, and the ability to last a long time or continue a long time. My preference is the UN definition, which is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So as I think about the world for my children and grandchildren, sustainability becomes a more and more important thing to me as a person. So at BT, we think about sustainability in terms of a circularity. We look at sustainable agriculture, sustainable economically, and what does our carbon footprint look like? So we're evaluating raw materials, materials handling, the manufacturing process, and what is the impact of our manufacturing. Our primary facility is located in India, and we're utilizing castor as a crop. And the beauty of castor is it grows in a semi-arid environment, meaning it's not putting pressures on water. It's also a gateway into agriculture for people socially, giving jobs to the people who normally wouldn't have them. And the beauty of this crop is that it can be harvested multiple times. We also use products like soy, which is also very, very good for the agrarian community. So we're liking that. Our manufacturing is done locally to the fields. So the crushing, the processing, the shipping are done geographically small area, which also reduces our carbon footprint. Our primary manufacturing facility is 100% renewable energy using a local area wind farm for electricity. And the boilers are generated or fired by the spent castor cake. And then finally, our original LCA, our life cycle assessment, shows us at about -9 tons of CO2 per ton product made. We think that's a little bit high. Would love to keep that number, but we're trying to be as credible as possible. We're now doing a second generation LCA, and we're hoping that that will be done any day now, or certainly during this year. So some traditional types of sustainable base oils. This is defined by the ISO 6743, which is really a hydraulic fluid classification, but it's been kind of adopted by the industry. And from oleo-derived products, there are triglycerides, which are really just natural vegetable oils, which essentially are natural esters. And then there are synthesized esters, of which the estolides are one, but there's a wide range of oleosynthetic esters. From the petroleum-derived sustainable fluids, polyalkylene glycols, and some polyalpha olefins are considered sustainable and also are biodegradable. There's a wide range of popular bio-base oils, starting with soy oils, and there's sort of the traditional soy, and then there's a high oleic soy. There are canola or rapeseed products, as I mentioned, castor oil. It's pretty hard to get these days due to some issues politically, but sunflower, safflower, palm, mustard, algae are all various types of bio-based renewable base oils that people are utilizing. Some of the benefits of bio-based base oils, people know these, but it has good biodegradability, typically low toxicity. So therefore, if it's to get into the environment, it has a very low environmental impact. These materials naturally have a very high viscosity index, which means their viscosity changes less per unit temperature change. So traditional petroleum oils will have a VI of about 100, and bio-based products will be somewhere between 150 and 200. As I mentioned, they're renewable. So every year you get a new crop. They tend to have high flash points, low volatility, and actually Mother Nature has made them highly lubricious so that they give a good lubricity and energy efficiency naturally. So if you know me, you know that I've dedicated my my adult career, if you can call me an adult, but I guess that's what most people would say, that I love bio-based products, and I've created my whole career around bio-based products. But can sustainability be more than just bio-based? And the answer is yes. Can it be reducing energy usage, such as reduced friction modification or improved friction modification? Maybe utilizing multi-grade oils that offer energy efficiency. Can it be extended drain interval? Would you look at that as more sustainable? So utilizing synthetic oils or better formulations might improve their sustainability profile. What about using safer chemistries such as non-zinc containing anti-wear additives or non-heavy metal containing additives? And can you reduce utilization of old hydrocarbons? Can you use re-refined oils or extend the fluid life? Perhaps looking at the ability to be either recycled or re-refined. When you look at re-refined oils, you look at it's an old hydrocarbon base, but it essentially has zero carbon or bio-based content, but it also has a very, very small, if negligible, carbon footprint. So it would be equivalent to utilizing a 100% bio-based material. Bio-based content is typically measured by the C14, the carbon dating. So it will show as old hydrocarbon, but it's new all over again. So where would I consider utilizing applications for bio-based products? Well, I like to say that anytime there's a big piece of machinery working in an environmentally sensitive area, that would be a good place to use a bio-based or environmentally acceptable lubricant. Marine transportation is one example of a market that has embraced the EALs, environmentally acceptable lubricants. And that was generally started by the US EPA in their vessel general permit, which mandates the use of EALs in oil-to-sea interfaces. Another area or application for bio-based or environmentally sensitive products would be total loss applications, perhaps greases, stern tube lubricants, chainsaw oils, cable greases, so that the materials, the lubricants are getting and greases are getting into the environment. I mentioned chainsaws. We talked about environmentally acceptable oils. Maybe you can do some sustainable engine oils. We've been making a passenger car motor oil that has bio-based content, and we also use some re-refined content for base oils. Maybe you're looking at bio-based greases, which have a tendency to get into the environment, high temperature processing oils, rolling oils, machine lubricants, and very importantly would be mold release type of materials that will get into the environment, one-time usage, and anti-dusting or dedusting oils. So bio-based alternatives as compared to fossil-based alternatives provide a wide range of benefits to society. It's reducing human ecological risk factors. I mentioned previously the enhanced environmental efficiency. There's less waste, and it reduces the requirements for finite resources, allowing those finite resources like petroleum and fuels where it would be it's advantageous to be derived from petroleum. Everybody wants to be sustainable. We all want to be puppies and kittens in green fields until we have to pay more for it. And that makes people a little bit concerned about moving forward with that. But there are many applications in many areas where people are willing to pay the difference because it's just a value proposition. First would be when it's driven by legislation. I mentioned the US EPA Vessel General Permit. The US Department of Agriculture has a bio-preferred program which mandates the use of bio-based, bio-containing materials. On the other side of the pond, the European Eco-label is driving a lot of use for sustainable and bio-based products. The Army Corps of Engineers mandates the use of environmentally acceptable lubricants in some of the working areas. And we're seeing a big driver also in rail applications and rail track and curve greases, and lubricants. We're also seeing investors and shareholders and stakeholders mandating the use of sustainable materials because they are trying to improve their environmental safety in governments. And a lot of the investment community, private equity, is saying, we will evaluate your ESG portfolio or profile when we evaluate our investments. And then finally, the stakeholders, we see that major oil and others are being pressed into reducing their carbon footprint. You've seen many companies that have said we will be carbon neutral by some such date. And I see that as a driving factor that's going to remain for quite some time. So how are we doing right now? How sustainable are we? I think we're more sustainable than we think we are. So for example, greases. Greases use thickeners today, like 12-hydroxystearic acid, which is bio-derived. And we're not claiming those type of credits for those type of materials. Metalworking fluids. Today, a wide range of metalworking fluids use materials such as polyracinoleic acid, also bio-derived. So there are some more sustainable metalworking fluids than we're giving ourselves credit for. How about sensitive applications where there's a marketing value proposition? Hydraulic fluids, and we all know that industrial hydraulic fluids tend to get into the environment through drips and drops and hose breakings. The same thing with gear oils, engine oils, and penetrating oils. So people are working towards that already in today's marketplace. The utilization of synthetics, as I had mentioned previously, being able to extend your oil change interval of the life of the fluid to improve your operational efficiencies can also be derived even from petroleum-derived synthetics. Reduction of friction. So reducing friction. Could you imagine a world that didn't have lubrication, how hard that would be? And by reducing friction and energy efficiency, you're reducing the amount of fuel necessary to operate your trucks and cars and hydraulic systems. So we did some work, and I wanted to share a little bit of what we've done in terms of coming up with a food-grade hydraulic formulation. What we wanted to do is use a high oleic soy oil with some estolide blend and an estolide straight product. We use conventional additive chemistry and formulated to meet just the standard ISO 46 and ISO 68 products. And what we did was we looked at the oxidative stability, and typically oxidative stability in bio content or bio-based materials is fairly low. And we found that using the soy estolide based product, we were able to make it a roughly 200 minutes, a little over in the rotary pressure vessel oxidation test. And that is suit for purpose in a light to medium duty application. But utilizing the estolide, we're able to reach best in class at over 700 minutes. The other weaknesses that we tend to see in bio-based lubricants is hydrolytic stability as measured by tan increase in the oil layer. And we found that all four of these met the requirements and were suitable for purpose. So we thought that that would be really important, especially with the requirements now for the Food Safety Modernization Act, FSMA, mandating the use of food-grade products in food handling equipment, including handling seeds and grains and things like that. So making a product that worked well, that met the requirements of the equipment, was really important. What was very exciting to me was we went to compare the performance in terms of hydrolytic stability as of the vegetable and estolide blend and the estolide with petroleum oil and a polyalpha olefin blend, so top tier mineral and synthetics. And we're able to show that the hydrolytic stability of these bio-based or bio-containing materials was every bit as good in terms of performance as the mineral and synthetic mineral materials. We also continue the testing in terms of the oxidative stability, which demonstrates to me essentially the life of the fluid before it breaks down due to oxidation. And while the polyalpha olefin did very, very well, the estolide blend product performed almost as well, outperforming the mineral oil, petroleum oil derived material. And of course, the vegetable containing material met suit for purpose, but it was not as good as the other materials. So can we do better? I say let not perfection stand in the way of improvement. Could we take 5 or 10% of a sustainable base oil and put it into our formulation? That would help us to avoid some sticker shock and some of the cost increase. Can we start with a clean sheet and design more sustainable formulations? Can we produce more sustainably? Can our manufacturing facilities be cleaner and consume less energy? Can we create longer lasting products, thereby extending the oil change interval? And we tend to forget about sustainable packaging. Can we utilize more sustainable packaging? So these are some of the very easy ways that we can improve our sustainability. We at BT like to talk about crawling, walking, and then running. So you can do that as well. So here's me, and my marketing lead, my marketing guru says that if you scan that QR code, you'll be able to find me. I'm a little old school, so here's my email address. I'd like to save a couple of minutes to open this up for questions, and I thank you in advance for your kind attentions.
We didn't get any questions during the presentation, Mark. I don't see any popping up right now. So looks like you got off easy.
Well, if anybody has any questions, please feel free to email me or come to the biosynthetic.com website and ping us. And then if not, then I'll give you 5 minutes back and I'll sign off. Thanks a lot.
Thank you very much. Nicely done.
Thank you.